Welcome to the educational research part of www.happynumbers.org. We're still working with single subject case or single case designs. In this video we'll talk about the multi-element design. And by the way, the materials and some of the graphs used in this video come from this source. It's Kennedy's book, Single Case Designs for Educational Research. Allen and Bacon are the publisher. Chapter 10, here are the page numbers, and here is the ISBN number. Again, I'm not in the business of promoting textbooks or selling textbooks or anything like that. I'm just presenting where this information comes from. However, if you are looking for a very, very good text on single case designs, this is a very good one. All right, let's take a look at the multi-element design. Now, typically at the AB designs use, well, and by the way, if you're not familiar with an AB design, you may want to look at the video under single case designs on the AB design first, because you'll need an understanding of that before we can, before this will be of any use to you. But typically the AB designs use gradual alternating between the A, or baseline condition, and B, intervention condition. And that's how they establish experimental control, alternating, presenting a baseline, then presenting an intervention, then withdrawing the intervention, going back to baseline, and then the intervention again. However, if we want to compare multiple conditions, multiple interventions, multiple treatments, an AB design will not work well for us. But a multi-element design can make this multiple comparisons feasible. Multi-element designs alternate between conditions, or interventions, or independent variables, or treatments. The interventions are alternated back and forth as a means of demonstrating experimental control, and experimental control relies on response differentiation. In other words, there needs to be a distinct difference between how participants respond to one treatment as opposed to how they respond to the other. If we have this response differentiation, then we can establish a functional relation. In at least two conditions being analyzed, responding by the subject or participant needs to occur at distinctly different levels to demonstrate experimental control. Let's take a look at an example. The graph portrays the number of disruptive behaviors per minute for a child with autism. So the y-axis is talking about a number of disruptive behaviors. So it goes from 0 to 10. And there are two conditions that are being compared. One is instruction using difficult tasks. So instruction, asking the student to perform difficult tasks, and instruction, marked by the solid black circle, instruction where there are easy tasks. And the researchers switched between the two conditions a total of 6 times. So on day 1, right here, they had instruction with easy tasks, very little disruptive behavior. Instruction with difficult tasks, pretty good increase in this behavior. Day 2, still with when easy tasks were used in instruction, little disruptive behavior. On difficult tasks, pretty different response. Same with 3. When easy tasks were used, low disruptive behavior. And when difficult instruction or difficult tasks were used, much more disruptive behavior. So we can see from this graph, if we are comparing the two interventions, instructions with easy tasks and instructions with difficult tasks, and our dependent variable is the number of disruptive behaviors, we can see that instruction that uses easy tasks decreases disruptive behavior, and instruction that uses difficult tasks increases. So we compared two independent variables, two types of instruction, one difficult tasks, one using easy tasks, and we have a response differentiation. There is a difference between the two treatments. So we would say, well, okay, with this student, we probably want to give instruction using easy tasks. So that's a very, very simple design, can be very easily done in a classroom. Not complicated at all. Let's take a look at another one. Here we had the dependent variable was reading comprehension of a student with learning disabilities. So this is reading comprehension. I guess maybe let's say the number of problems they got right on reading comprehension. It goes from 0 to 10. There were 3 conditions. The first condition, represented by the round circle here, was self-questioning, required students to answer a set of prescribed questions after reading a passage. So one condition that they used, or one treatment to increase reading comprehension, was a thing they called self-questioning, where they required students to answer a set of prescribed questions after reading the passage. And we can see that graph here. This is the responses. So students seem to comprehend pretty well when they were using self-questioning, or this student. The second one, which is the upside down triangle, was story mapping. The second condition, story mapping, had students draw a graphic representation of what they had just read in the passage. So the second condition, they had students make a graphic representation of the passage they read and then answered questions, and that graph looks like this. Somewhat similar to, but a little, there's some response differentiation here because the self-questioning is higher almost in all cases except in this one particular one. And then the third condition, here they had 3 interventions that they used, was that there was no intervention. It just required students to read the passage with no supplemental aids, and that's represented by this graph here with the squares. And so the researchers altered these 3 different reading conditions, and they were altered across days and in a counterbalancing fashion. So day 1, they did no intervention. Day 2, they used story mapping. Day 3, they used self-questioning. Day 4, they used self-questioning. Day 5, story mapping. Day 6, no intervention. So they just counterbalanced it back and forth. Well, this particular piece of research, the way it looks here, does show a response differentiation, and it seems that self-questioning is the most effective technique, and that no intervention at all is the poorest. So there's experimental control or functional relation has been established here between self-questioning and reading comprehension of a student with learning disabilities. It seems that the self-questioning strategy, the self-questioning intervention, was the most effective. So that's it. That's very simple multi-element design. Again, very usable in classrooms. Now, there are limitations of the multi-element design. One limitation is behavioral reversibility. If a change in behavior produced by an independent variable cannot be reversed by the withdrawal of the intervention, then the multi-element designs are inappropriate because the student is not going to unlearn anything. And there may be potential interaction effects. If in that last example, students were getting 3 different interventions to increase reading comprehension, there may be a cumulative effect of those interventions, so that may present a threat to internal validity. And there's this URL down here, which is a great one. Will take you to a website where you can print out every article that is for free that has ever been published in the Journal of Applied Behavior Analysis, which is wonderful. So if you're interested in looking at a piece of research that uses multi-element design, here's a very good example, and it is in the Journal of Applied Behavior Analysis. So you can just type in that website, go to the year, and pull up that journal and take a look at what a multi-element design looks like. Well, that is it for Multi-Element Designs. Thank you very much, and we'll see you next time.